not? Yes.
Yeah, yes, yes.
Okay, so as you see here, the title talks about the on the way. So it means that there's still a long way to control in in the way that we expected, the way we desire, we wish the process of the corrosion process, not only, of course, inside of the buildings, not only inside of the bridge, but you showed that our colleague showed that it's very important also to protect some important piece of art that are made recently with this material that has been called once, it was called the fluid stone, has been called by Pierluigi Nervi. With my colleague Andrea Micheletti, Alessandro Tiero, we are trying to investigate the possibility to control the corrosion, mostly because recently we know that in civil engineering we have some very bad experience connected, of course, with the corrosion, but mostly with the bad maintenance. And there are also something that I experienced related to the cultural heritage field. For instance, you can see here one I found somewhere this interesting original drawings for the design, the project of the renovation of the roof of the Santa Chiara Abbey, the church, a very famous church in Napoli. And this reconstruction is substituting the original wooden beam with new reinforced concrete beams. And so, and you can see here all these this part related with there's stirrups, there are longitudinal beams. Here there is all the beams related with you can see the steel is here, iron bar, and here the cross section and so on. So it's a really reinforced concrete structure, but is inside of one church. So what can happen? This church, of course, the load on the external part on the wall has been increased pretty much once they substitute the wood with concrete. But
I'm Andrea Micheletti. I think you are not sharing the right window.
Thank you. Thank you. Is this one? Grazie.
You need to. I think you need to redo the sharing to select the right window.
Okay. Thank you. It's okay. It's right. It's right. I should go here. Is this one?
Yes, that's
yeah.
right.
Thank you. So you see here, this is a roof. I thought this is the wooden, the original wooden roof was substituted with the reinforced concrete truss, and then you can see here the beams. And here there's another intervention on the cultural heritage. This is a facade or Santa Croce, is a church in Lecce. And there was an insertion of, you can see the line, the black line, dotted black line. They show the insert of the bar. They're put it inside to reinforce the facade. Of course, the facade was made by masonry, but later on. They appear this sort of, you can see this sort of red crack, and then if you try to connect the red crack with the line of the iron bar, you can see that they're almost overlapping. It means that this is the effect of the corrosion of the iron bar that grow up and then try to expel there's an interesting verb from English. They say the spalling. It means that the protection of the cover of the iron bar is going to be expelled because the increasing the volume by the rusty iron. Here we are in Palermo. Here there is in the 80s it was organized the big restoration of the La Zisa. La Zisa is a complex, it's a very famous complex of the 12th century. And this kind of this is a Normanno, from that time, 12th century, and then all the part was being reconstructed by with vault in reinforced concrete. So you can see here this part is made by you still see here the cage of the reinforcing bar and the stirrups and so on. So this is another application of this kind of concrete. And here we are in Amalfi. I think everybody knows this place, Amalfi Coast. This is Amalfi Cathedral, and the Amalfi, the original church, is back to the go back to the 10th century, and in the 1958 it was organized a sort of reinforcement of this facade, and inside there is also a sort of there's a kiosk, there's a sort of there's a sort of many bifora, two holes, windows you can see here, and then everywhere was filled with this kind of diagonal drill and diagonal bar, just a simple iron bar, and injected with the concrete. This was pretty common at that time. There was very famous construction company in Naples that was proud to distribute all over the Italy this kind of intervention. Of course, it was not intentionally in the bad way, but in that moment, the concrete was considered the most innovative solution to prevent collapse of buildings, of monument, and then this was one of the application that was done in Amalfi. Of course, the problem is that this kind of work cannot be removed, cannot be absolutely removed once are put in the site. And now I want to show you this interesting example. This is very I can say emblematic example. This is we are in Paestum. Paestum is South Italy, south of Salerno, and this is an area like other part in the south of Italy, belonging to the Greek culture. And in Paestum there are three main temples, and one of this is a temple of Cerere. Cerere is a Cerere Giunone, the god of the fertility, and this is a temple dated 6th century before Christ, and as you see, this is a colonnade. There are some horizontal lintel beams, and all the system, of course, is organized with a drum column. Drum column is made by all this kind of drum, rocchi in Italian, and these are just there's very little knot in the middle to prevent the sliding, But this kind of rocks has been proved by very clever mathematicians and engineers. They prove that when there is an earthquake moving one side of another one, it seems that these rocks should fall immediately down. But indeed, the movement is such kind of movement that is very, very magic, that make this kind of rocks stay still there, even moving in such a way that it's going to fall down. But indeed, it stay there and not and not stay and not fall down. But what happened in 1962? There was this kind of let's say this fashion trend to reinforce the monument with this innovative solution. I show you again this kind of situation, like this one in Lecce, and this is in 80s, but this kind of intervention is 1958. So in the 60s, in the 70s, it was very trendy to work. You see here is 1958. It was very trendy to work in this way. So what happened? That some the same company, construction company, with some very clever engineer, but not so expert, and probably not so expert of masonry or rocks or something like that. They could not understand the situation of the system, and then they want to just to replace the system and reproduce a sort of a frame, like columns and beams in the building. And then they want to connect the columns with the building, and then they went there, and then they put this kind of long bars. So it means that connecting all the drum between them, so the drum cannot move anymore freely like before. So they are connected like a beam. So just like a sort of columns and beams in the building. So there was drilled, of course, and then there was put these bars, just a simple bar, and then there was injected some concrete to prevent this kind of situation, to prevent the rusties according with their situation. And then after a while, few years later, it happened that this kind of you see here, there's one columns that disappear. Why disappear? Disappear because during the summer, there was a storm and a lightning, a thunderbolt hit the temple, and one column exploded. And then here you see here in this small picture, this is taken from the newspaper, local newspaper, that said that the engineer went there to check, and then they say, look, if we didn't have any kind of bar inside, because here there was a bar inside, you should remember, so they would be hanged by this kind of structure. If there were no our hanged bar, all the structure will collapse. But I can say, so they say they saved the entire colonnade, but my opinion is a little bit different. I think that all this kind of bar put inside and outside everywhere, they act like a sort of we can say like Faraday cage. So they attract the lightning, and then one of these lightning discharge on the ground, and then the columns blow up. This is we are in India now. I've been recently in India, and then after 20 years, I've been again in the same place to check how was the situation. And this is Elephanta Caves, is one island just a few kilometers of boat from Bombay, and is an island, of course, is near by the sea, and this is related to the 8th century after Christ. So let's say 1,300, 1,400 years ago, and you can see is a sort of digged under the stone of the rocks of the mountain, and then there are all these kind of columnade that support the structure. But the situation is that because there was some problem about some colonnade, they want to use again this kind of miracle material, and then they want to use this kind of reinforced concrete, putting some iron bar and net, spiral, everything. This was made in the 70s. It seems that, all over the world in the 70s, in the 60s and 70s, there was such kind of idea that using the concrete was very, very good idea. But of course, the temple is nearby the sea, and the cover is very limited, and even there's a cover, the situation is very dramatic. And then you can just see the carbonation of the concrete is evident. You don't need to touch by hand. You can see by your eyes, and then you can see also what happened here near this kind of capital, and you can see here the tentative to make a ring around the capital, but the situation is pretty bad. And this is some of these reinforcements are back to the 1972. Of course, in this kind of example I show it to you, it's evident that in that moment the idea was to do the best. So all the engineer and the company, construction company, even the people that belonging to the Minister of Cultural Heritage, they believe that the concrete could be a good solution, but indeed we don't have no compatibility of the materials, and then no compatibility for the original static system. If you put, for instance, on the vault, you put some 10 centimeters of next new vault made by concrete, you will delegate all the loads to the new vault, and the old one will lose and will be discouraged to support again still the loads, and then will fall down. And also reversibility. This is most important part. Reversibility is absolutely not permitted anymore to this structure. Once you put concrete and then you make some drill inside of the for instance the columns of pestum, you cannot do nothing else there in pestum. You can put just seal the extreme part with some wax to prevent corrosion, but you should pray that the rusty bar will not increase the corrosion and will not blow up all the columns. Otherwise, will be very dramatic. It's very interesting what Antonino Giuffre, a professor from Rome University, wrote a piece of one paper. The title was "Pietà per I monumenti." It means please have pity on monuments, considering all this kind of we can say very fanatic way to use concrete for the structure, for the old structure, for the monument. Now we are now thinking, what can we do what can be our contribute for the new solution, for the control, the monitoring of the corrosion. we have a look to the state of art, what is now around, and we saw that there are some interesting infrared thermographs. So if you make some pictures, and then you can probably emphasize this with heating the part or doing something else, you can make evident of chloride content. Or if you use, for instance, high frequency ultrasound, you can use a typical effect to control how compact is the concrete, mostly the cover. So the cover is a sort of protection for the bar they are inside, and then we can also some typical valuation of potential. So we have one open circuit potential. This is called OCP, and then this is this is controlled by connecting the bar and the concrete. Or we can have a surface potential, and then you can connect without contact, without make a hole and without damage. So this is still a not destructive test. You can connect on the surface, and then you can try to control conductivity of the two parts of the concrete. Of course, there are some correlation tests. You could have a lot of information, and of course, you should have many mapping point. Otherwise, you cannot have enough information. And but you have a large uncertainty because of several parameters affecting and factors affecting the results. So you need multiple and dense measurement in order to map large areas and assess the risk of potential corrosion. Then there is another point of view. We talk about the concrete. So control the resistivity of concrete. Of course, this is a sort of indirect measurement. So higher resistivity, it means less risk of corrosion. It means that more difficult for the flow to move from one anode to another cathode. Of course, when the concrete is pretty good, the porosity is very small, and we have high resistivity, everything is paradise. But if you have a large porosity and you have a low resistivity because the concrete is not dense, you have more favorable situation for communicating from one anode to another one. So this is a sort of, in the picture you can see here, a sort of a typical device that you, from external part of concrete, you can evaluate this. But look here, you always have the situation to connect the device with the concrete. So you should make wet the concrete. And the measurement of course is control the porosity of the concrete. What we are looking, so probably is a sort of multiple embedded sensors. So we want to have something that connected multiple information, and then with some correlation, we can use this kind of evaluation. So it means that if we have a sort of internal part that is inside, not only from outside, but we want to connect with the bars and so on, it will be interesting to know what happened. So, and also if we can integrate the sensors with some micro AD converter, we can also send directly digital data, and we will avoid some noise due to the typical of the analog connection. So in this moment, we are focusing on triple sensors equipped with in such a way that can measure humidity, pH of acidity of concrete, and the potential of concrete rebars. Limits are the condition of the construction usually are quite difficult on construction site from laboratory, so we need to adjust our situation. Also, the reinforcing bar behave like a cage, so we should never forget that connect all the bars are connected electrically one with each other, and measurement needs always the contact point to be wetted. So this is another interesting point. And also we need to train work worker to install properly the device before to build the situation. So we probably we are going to prepare one device like this one. We insert and leave there, and then also with some electronics, miniaturized electronics, they are largely available and affordable and cheap. We can make some monitoring feasible and reliable. These sensors are very small now, and then we can put in the corner of the beams or the columns or all over the house, or the any kind of things. We can talk also about bridges, for instance. We can control the humidity, oxidation, temperature, stress, strain, acceleration, everything. Permanent monitoring. This is our idea. Permanent monitoring inside of this kind of so-called Internet of Things. But we are not talking only about Alexa, about domotic, but we are talking about a smart building in the sense of structure. So we want to put several sensors inside of the structure, and with some wireless system to connect and to send to some sort of control panel under the building, in the basement, for instance, where there is a red light, we can have some problem. When there is a green light, we are okay. So the situation is that today we want to assess the condition of concrete and risk carbonation and corrosion for the reinforcing bar. And we want to have a device affordable and reliable, and also tailor the network that could control and connect all this data. The difficulties in the moment are several. I cannot hide this because the laboratory is something and the on-site is something else. The control for the moment only on the surface, and we can have a random point measurement, but we want to generally distribute it all over. And then we won't see the rusty bar only by cutting a part. And also we should perform the measurement on site. This is very important. So we want a sort of a building like a sort of car. So we want to control everything in the building. This is also a contributing to corrosion. Thank you very much.
Thank you, Donato, for very interesting presentation. We have time for one or two questions. Okay, if not, only my comment that because I started the InnoConcrete project thinking about like a wearable sensor for concrete-based structure, and so I'm totally agree with Donato about this view that able to implement the safer building. Thanks again.
Thank you.
Okay, we can move toward the next speaker. Noemi Colozza is postdoc that work in our team, and